Hello guys, welcome to Astralism TV. Today we are going to discuss about temperature and its measurement. So when we say temperature and its measurement, what does it mean?
So the concept of temperature is saying that temperature has its root from the idea of hotness and coldness of the body. Based on our sense organs of touch, it is proven beyond reasonable doubt that many properties of matter that we can measure depend on temperature. So the length of a metal rod, steam pressure in a boiler, the ability of wire to conduct an electricity,
And etc. So those are all affected by temperature. It's defined as the relative measure of hotness. As the relative measure of hotness and coldness of a body or system. Related to kinetic energies of the molecules, we define temperature as the measure of the average random translational kinetic energy of the molecules. So temperature is measured in degrees Celsius or degree centigrade. That is and degree Fahrenheit. Degree Fahrenheit. Yes, that is degree Fahrenheit, which is also but it is SI unit is Kelvin. Yes, Kelvin, which is also K.
So how to measure a temperature of a body? So in this aspect, a temperature measuring instrument, which is thermometer, is placed in contact with the body. As two bodies interact, the thermometer becomes hotter and the body cools up a little. After the thermometer settles down to a steady value, then temperature is read off. So measuring temperature has brought us to thermal equilibrium. When we say thermal equilibrium,
This is when two bodies are in thermal contact and there is no net flow in between the two bodies. Zeroth law of thermodynamics. When we say zeroth law of thermodynamics, zeroth law of thermodynamics said that if body C is in thermal equilibrium with body A and B, then A and B are also in thermal equilibrium with each others. So let me draw this so that for better understanding. So zeroth law of thermodynamics can simply be explained using this diagram. Yes, here they are in contact. Yes. Here they are in thermal contact. And this is an insulator separating the two bodies. This is system A, then system B, then system C. So when this body C is initially in thermal equilibrium with body A and B, then definitely A and B are also in thermal equilibrium with each other, despite the fact that they are separated with an insulator. Yes, insulator. Despite the fact that they are separated with an insulator. Why? Because they are in thermal contact with body C. So this is how to explain zeroth law of thermodynamics with diagram. That is, thermometer can simply be defined as a device used for measuring temperature. So to make thermometers useful, we must mark a scale on them. So we must mark a scale on the wall of the thermometer, that is numbers, so that that thermometer will be useful. So temperature scale are the marks or numbers. That is, temperature scale is a numerical marks on the wall of the thermometer, be it degree centigrade, degree Fahrenheit, as well as Kelvin. They are all having numbers. It is having two fixed points, that is the upper and the lower fixed point. Yes, it looks like this. Yes, and the numbers are situated here. Yes, this is the scales, that is scales, and this is the upper fixed point. Yes, here it marks 100 degrees centigrade, which is also boiling point of a pure water, while here yes, here it marks 0 degrees Celsius, which is also freezing point. Freezing point of a pure water. So mind you, at a temperature below 0 degree, the number of degrees centigrade is negative, will always be negative. And also the scales, the interval between the first scale and the second one is called 1 degree Celsius. 1 degree Celsius. So this is a Celsius scale. is having only one fixed point, which is called triple point of water. That is, water at 3 states of matter can exist in that level. That is solid water, which means ice, and also liquid water, together with water, vapor. They all coexist in that level, and it is having a value of 273.16 Kelvin. So these are the types of thermometer. We have liquid in glass thermometer, resistance thermometer, and also gas thermometer. Where gas thermometer is divided into two. We are having constant volume, that is constant volume gas thermometer, and also constant pressure gas thermometer. So let's explain them one by one quickly. So this is liquid in glass thermometer. It is having two fixed points, that is the upper and the lower, where the upper is 0 degree and the lower is 0 degree and the upper is 100 degree. And this is theta, that is temperature at somewhere around here that you are measuring. So this is the formula for calculating, for working example under liquid in glass. And also under liquid in glass we have two liquid substances that are commonly used, that is where L naught, where L theta is equals to length or temperature at somewhere. And also L naught lower fixed point L100 is the upper fixed point. So we must put our data into the formula given. So as you know, here what we are looking is L theta. So we have to put them in. L in theta is equals to L theta minus L naught over L 100 minus L naught multiplied by 100. Our theta is what? 17 to be equals to L theta, since it was not given, then minus L naught. L naught is 1.88 over L100 is 2.28 minus this minus the L1 1.88 multiplied by 100 degrees centigrade. 100 degrees centigrade. So let's work it. 6.8. Yes, we are going to have 6.8 to be equals to, open bracket, L theta minus 1.88 all by this 100 degrees centigrade. And also it will give you something of this nature, 6.8. Yes, after you multiply this by this and also multiply this 180 by this, you will get something of this nature. Yes, you get something of this nature. 100 L theta minus 188. If you take this to this side, definitely you are going to have this 100 at the other side. That's 100 L theta. So definitely this negative will be positive. 188 to be equals to 100 L theta. So if you sum them together or if you add them together, then divide both sides by the coefficient of this of this L theta, then definitely you are going to have 1.948 to be equals to L theta. So therefore L theta is equals to 1.948 centimeter. So the reason why we work this example to find this L theta is that if you are asked to find this theta is normal, just substitute the values into your formula, you can get it. So this is the little bit confused one, so that's why I decided to bring it. Resistance thermometer. In this thermometer, change in electrical resistance of the coil of the fine wire with change in temperature is measured. Remember, it is platinum that is used in this thermometer as a thermometric substance. And also resistance thermometer is more precise than the other types of the thermometers. R theta, R naught, R100, R naught by 100 degrees centigrade. So this is gas thermometer. A gas thermometer does not depend on any specific property of a material used. So therefore, gas thermometer is categorized or is divided into two. We have constant volume gas thermometer and also constant pressure gas thermometer. So this is constant volume gas thermometer, and it is given by this formula. and we have already known the parameters. This is temperature, length at somewhere, temperature at somewhere, temperature 0 degree at 100 level, then 0 degree by 100. This is constant pressure gas thermometer. So they are all having the same formula.